Good morning, all the participants. Shall we start today?
Good morning.
Good morning, sir.
Yes.
Good morning. At least, shall we start first attendance?
Yes, sir. Good morning,
Yes,
sir.
sir.
Good morning. Dr. Dipti Malviya.
Good morning, sir.
Yes, good morning. What about roll number 1, Dr. Dipti Malviya? She is yet to join. Anyway, we'll go for roll number 2, Dr. Rushali Parkhi.
Present, sir. Good morning.
Miss Neetu Amlani.
चना भी आई उसको भी दो देगा बोलना
Miss Neetu Amlani.
आता येतीलच माहिती पावसामुळे अटकल्या असतील येतीलच कॉलेजला.
हो ठीक आहे पावसामुळे
हो,
आपण
हो.
थोडंसं म्हणून थोडं उशिरा पण सुरू करतोय. ऑलरेडी
आहे,
आवर
ठीक आहे.
गेस्ट स्पीकर हॅव जॉईन.
येस येस सर.
डॉक्टर नीरव पंड्या.
Yes, sir. Present, sir.
मिसेस मिनल राजदेव.
प्रेजेंट सर
डॉक्टर सुपर्णा मुरकुटे.
Present, sir.
डॉक्टर अमित काळबांडे.
Present, sir.
डॉक्टर अर्चना महाकाळकर.
प्रेजेंट सर
डॉक्टर विनोद डोंगरवार. डॉक्टर अरविंद सोमनाथे. डॉक्टर श्रुति घरडे. पल्लवी देशमुख. डॉक्टर पल्लवी देशमुख. She is also not there. She is a very regular participant. डॉक्टर मीनाक्षी कांबळे.
Present, sir.
डॉक्टर शील.
Present, sir.
मिस्टर विवेक माणिक. What happened to Mr. Vivek Manik? He's also not there. Dr. Rajesh Sonkusre.
Present, sir.
You will have to take care of the
Yes, sir. Introduction and
guest speaker of the doctor first session, that is Dr. Ramesh Kumar.
okay. Okay.
एक्सक्यूज मी सर सर नीतू अमलानी प्रेजेंट
Neetu Amlani. Okay. Then Dr. Vishal Daulatkar. Dr. Vishal Daulatkar. Vishal Daulatkar.
Present, sir. Present, sir. Present, sir.
बायोडेटा मिळाला तुम्हाला ग्रुपमध्ये पाठवला होता.
हो सर मिळाला.
एवढा मोठा वाचू नका, थोडस त्याला शॉर्ट करा, ब्रीफ करा त्याला.
बरं.
देन डॉक्टर स्वाती यादव. मिस्टर केरकट्टा.
Yes, sir, present.
Yes. Miss Kani Mozi.
Sir, present, sir.
Yeah, very good. Then Dr. Shikha Avasti.
Sir.
So our guest speaker have also joined. We will be starting our first session with Dr. Ramesh Kumar sir. Actually, Dr. Ramesh Kumar basically is a principal scientist and working as a divisional head of NIRI Nagpur. Basically, he is an analytical chemist. He did his PhD from University of Chennai. And today, he is delivering his presentation on microplastic in water environment. So now I would like to request Dr. Rajesh, please introduce the today's guest speaker, Dr. Ramesh Kumar.
Thank
Dr.
you, sir.
Rajesh, please proceed.
Thank you,
Yeah.
sir. Am I audible?
Yeah. Yes.
Good morning, all of you. I am Dr. Rajesh Sonkusre, Assistant Professor in English. I am working in district Chandrapur. I would like to thank HRDC UGC Nagpur, uh, Dr. Praveen Mishram, coordinator of this interdisciplinary refresher course in environmental science, and shouldering me an opportunity to introduce an illustrative personality in the field of environmental science, Dr. A. Ramesh Kumar, for the first session today. Dr. Ramesh Kumar is a principal scientist and associate professor of CSIR MIRI. He conferred with PhD in analytical chemistry by University of Madras in 2008. He has vast experience of 27 years with specialization in environmental analytical chemistry, persistent organic pollutant, that is POPS, hazardous waste management, and microplastic. He is also an associate editor of Journal of Indian Association for Environmental Management. There are 6 PhD holders under his able supervision. He has published voluminous 50 journal publications, and he has attended more than 75 conferences, organized more than 25 workshops. He has reviewed 25 journals and 6 scientific societies. He has a member of 6 scientific societies. Let me quote few lines from Sanskrit. Vidonna Nipuna na eva tulle kadachana Swadesha pujate raja vidwan sarvatra pujate. Being a scholarly scientist, he spread his wings to the different countries, and like Switzerland, Czech Republic, Thailand, and Indonesia. It is indeed an honor and special privilege and pleasure to welcome you on behalf of my colleague of refresher course, Dr. Ramesh Kumar. Over to you, sir.
Good morning for introducing me. Thank you very much, Dr. Praveen Mishram, for giving this opportunity. Am I audible?
Yes,
Sir,
sir.
yes.
Okay. So, a kind request to all the participants. So, I would like to see all of you. So, could you please switch on your camera? Yeah, please, all of you switch on your camera so that we can at least see our face. Indeed, the pandemic has taught us several lessons, and online meeting is one such lesson. And it is a good thing that even though we are sitting in different parts of the country and we are able to attend such type of refresher courses and training programs. So online meeting, it is a one good thing, but of course, with time it gets bored. But we have to be content with the both the merits and demerits of everything. Okay, thank you very much. I once again thank Dr. Praveen Mishram and RTM Nagpur University for giving me this chance to share some of my experience in the field of environmental science. So as you are aware, environmental science, it is in fact a multidisciplinary science. So different subject areas are covered in environmental science, and in fact, working together with all the subjects that gives a better output in the field of environmental science. So today my topic of discussion is microplastics in the environment. So this is one of the very current hot topic pursued by most of the research institutions as well as universities world over. It is identified as one of the global environmental problem. So we all are aware that we are living in the era of Anthropocene. I hope all the participants might have aware about the word Anthropocene. So human activities have reached at very peak. So in the current scenario, human activities have attained a very large influence in the global context, and various international agencies are taking cognizance of this problem, and they are trying to solve this problem, like climate change, then loss of biodiversity, environmental pollution, especially the pollution due to chemicals in the environment. So these are identified as one of the global problems, and several countries are taking several steps to mitigate or reduce this problem. So one such problem is due to the use of plastics and its associated consequences. So we all know that plastic is one of the it cannot be separated from our day-to-day life. It is very intimately related to our day-to-day life, and in fact, plastics brings a lot of positive things in our life. So without plastics, we cannot think of the modern way of living. So plastic has numerous benefits to the society. At the same time, there are some adverse effects due to plastics if the plastics are not managed properly. So I will be discussing all these aspects in my talk. So my scope of the talk, it includes plastic waste and microplastics. It is an emerging pollutant of global concern. Then plastics, not only it is due to the size or the physical state, there are many chemicals are associated in the plastics. There are many additives are present in the plastics. So it is not only the plastic particles. In fact, the chemicals are the additives which are present in the plastics that also pose a serious problem. Then we need to recognize that the plastic pollution as well as microplastic contamination, it is everywhere. It is a ubiquitous phenomenon. And our current knowledge about the, I will be summarizing about the current knowledge on the risk and the probable health effects of microplastics, and what is the way forward to mitigate these problems. That is the sound management of chemicals and waste. So I will be, my presentation is organized in this way. So at the end of the presentation, we may have some discussion, maybe around 10 to 15 minutes. We can have discussion, and in between, if anything is to be discussed or any intervention is required, you are welcome to interfere. Right. So before getting into the topic, let us know something about the plastics. What are these plastics? See, plastic production, it started in the year around the 1950s. So in the middle of the 19th century, plastic production has started. And currently the global annual production of plastic is around 330 million metric tons. So this 330 million metric tons, it is very close to the global human biomass. So if you take the weight of all the world population, it is also very close to 390. So far, the annual production of plastic per year is 330 million metric tons, and this production is expected to double within the next 20 years. It will be crossing around 630 million metric tons in the next 20 years. So at the same time, the annual global production of municipal solid waste, it is around 2,190 million metric tons. So we all know that municipal solid waste, that is the waste which are producing in our house. It also contains, we also dispose plastic along with the municipal solid waste. So roughly the global average of plastics which are entering into the municipal solid waste it is around 10%. So if we calculate the 10%, it comes around 239 million metric tons of plastic waste is generated per year. And this plastic waste generation per year, it is expected to reach 300 million metric tons by 2040 and 380 by 2060. Then let us see the production, global production, as well as the use of polymer resins. So here you can see the different categories of plastics and their usage details. So if we see the plastic polymer wise, globally, low density polyethylene and high density polyethylene. So these two combinedly, it constitute around 40% of the plastic production, both the low density LDPE as well as HDPE. And most of these LDPE as well as HDPE, they are mainly used for the consumer and consumer products. Mainly, they are mainly meant for the one-time use or single-use plastics. Then next comes the polyvinyl chloride, PVC. They are mainly used for the purpose of tubing and water conveyance pipes. Then next comes the polystyrene, PS. So this polymer is mainly used for making of this disposable cutleries and other domestic products. Then polyurethane, in fact, it is a foam. Most of the this cushions, sofa, then in apparels, then gloves, then most of the bags and chairs, furnitures. So all these are one of the mainly made from the polyurethane foam. Then comes the PET, polyethylene terephthalate. It's mainly used for the PET bottles as well as other containers. So one of the good characteristics of this PET is it is of very lightweight. Then comes the other type of plastics. Mainly their usage constitute around 20%. So then comes the polypropylene. Polypropylene is a little bit hard. So it is mainly used for the usage of these buckets and other containers. Then some of the multiple use, repeated use containers. So these are some of the different type of plastics and their use worldwide. Then if we compare the plastic usage in industrial sector wise, packaging industries. So mainly this LDPE as well as HDPE, they both constitute, they consume around 36% of the packaging products. So this includes all sort of packaging, both the domestic as well as industrial sector. Then comes the building and construction sector. It consumes around 16%. Then textiles, it forms a major chunk, around 14% of plastic, mainly the polyethylene, polyester, as well as other polymers. Then consumer and institutional product, it consumes around 10%. Then comes the electrical and electronic items, it constitutes around 4%. So this is the usage pattern as well as the industrial sector wise consumption of different type of polymers. Then let us come to our day-to-day life. We use previously human beings were using domestic items made up of wood, metal, as well as glass. Then slowly all these our products are replaced by plastics, because plastics has various advantages. It is in fact a miracle material which contributes to various societal benefits, which includes very lightweight. Plastics are very lightweight. If you take, for example, if you take a bucket made up of plastic as well as a bucket made up of a steel, obviously, plastic comes in different colors. It can be molded into different shapes. It is very ultra lightweight. It is non-rusting, and it contributes to. It is aesthetically, it is more preferable than the metal articles. So all these characteristics are very positive for the modern way of living. So we have adopted using plastic items in place of wood, steel, as well as the glass items. So because of this, plastic items have become a very integral part of our daily life. And if you look at the healthcare sector, they also use a lot of disposable items. In fact, after the introduction of disposable items, like for example, syringes, gloves, and other disposable medical devices, the infectious diseases are very largely controlled. So this is one of the major societal benefit out of the usage of single-use plastics, especially in the healthcare sector. Also in the food industry, it increases the shelf life of the food. Most of the food items are coming in the, you can say that it is called as a multi-layer plastics. So it contains 3 layers. Inner layer is made up of aluminum sheet. Then comes the plastic. Then comes the paper layer. So this is called 3 layers. This is called as the multi-layer plastics. Or you can also call it as a the higher end of this multi-layer plastic is called as tetra packing. So all these things have contributed increased shelf life of the food. So when the food items are wrapped in this multi-layer plastics as well as this Tetra Pak, its shelf life increases. For example, milk packed in this Tetra packing, it increases the shelf life. Similarly, you might have come across the fruit juices which are coming in the Tetra Pak. So it increases the shelf life of the food. At the same time, it also contributes towards the hygiene and sanitation of the most of the food packaging. Then global production, it is 330 million metric tons. So if you consider the average daily usage of plastics in different countries, if you look at the United States, the per capita consumption of plastic is 109 kg. Then in European countries, it is 65 kg. Then our neighbor China, it consumes around 38 kg, and Brazil 32, and India, it is per capita consumption is only 11 kg. And the global average is roughly it is around 28 kg of plastics. So this is the per capita consumption of plastics worldwide. And if you look at the compare the United States and India, roughly the per capita consumption of plastic is roughly it is 10 times more than India. Then why it is of a major problem in India? Because we are in developing countries, and we don't have sufficient capacity to manage our waste which we are producing. Even though our consumption of plastic is 10 times lower than the developed countries. So that is one of the major problem. At the same time, our population is also roughly it is around 3 times as the population of United States. So compared to other countries, Europe and United States, our major problem is population as well as our waste, which is not being managed properly. So all of you might be aware that most of the domestic waste, that is the municipal solid waste which we generate, it's currently it is going only into the dump site. Nearly around 90% of the municipal solid waste, it is going into the dumping site. And whenever you go to a new place or enter into a new city, you are welcomed by a mountain of garbage. Almost in every city, you can see this. For example, if you go to Delhi, and you will be welcome from if you are coming from Noida side or UP side. Is this slide visible?
Yes, sir.
Yeah, okay. Because there is power cut. Right, good. So there is a huge Hasipur dumping yard is there. Similarly, if you go to any cities, for example, in Chennai, there are three places these municipal solid waste are dumped. So every city has its own dumping yard in the outskirts of the city, and it is currently it is one of the major problem faced by most of the our municipalities as well as town planning authorities. Very difficult to dispose the municipal solid waste because we do not have the sufficient infrastructural requirement which is required for managing the municipal solid waste. Right. Yeah, I have explained, and you can see this is one of the major scenario which normally we encounter in Indian cities as well as other developing countries, including China. So always there will be, if you look at one side of the city, it will be very beautiful. For example, this is Mumbai. You can see the Worli sea face. It is a very beautiful. As well as in most of the cities, for example, civil lines will be very beautiful. At the same time, if you move towards the outskirts of the city, you can see this type of scenarios. This is quite common, but during the last 10 to 15 years, this situation is improving. And this is the case of our most of the rivers as well as water bodies. You can see most of the municipal solid waste along with the plastic waste, which is dumped into the banks of the water bodies as well as rivers. And a lot of our cultural as well as our attitude and as well as our way of life contributes towards this. So we have adopted the culture of use and throw. And our attitude, and even though most of the people are aware about the waste disposal and other awareness, we have much awareness, but still we do not follow the whatever we have learned. So as a result, you can see a lot of municipal solid waste as well as plastic waste is dumped into the our water bodies. And some of our cultural practice also contributes towards this, and I'm not going much into the detail. Right, this is another one scenario. So it is not only the water bodies, most of our railway lines which are entering into the cities, the scenario is more or less same in most of the cities. But slowly the condition is improving. This is the most scenario not only in India, in most of the other South Asian countries as well as other Asian countries. Right. So what are the effects of environmental effects or adverse effects of this plastic waste which is lying or dumped into the environment? You can see that most of the stray cattle, including buffaloes as well as cows, they consume this. They mistakenly consume this plastic waste, especially the single-use plastic, and it get into their stomach, and sometimes it get entangled into the intestine as well as stomach, and it ultimately lead into the death. I have also seen, noticed a lot of such animals, especially buffaloes and cow. They consume this plastic, probably mistakenly, knowingly or unknowingly they are consuming it. But ultimately, this plastic which is consumed by these animals, it cannot be digested. So it get remain in their stomach undigested. Sometimes it get entangled, obstructing the intestine, and finally it leads to the death. Then, in addition to that, our cities are, most of our cities are not planned. So because of this dumping of plastic waste, it chokes the drainage lines, and one of the reasons for flooding is due to the choking of drainage lines by the plastic and other waste. Then the ingestion of plastic, it is not only the plastic per se, but the some of the additives which are present in the plastic, it also poses very harmful effects to the cattle like buffaloes and cows. So ultimately, these chemicals finally they get into the milk, and when human beings consume their milk, we are also exposed to this type of chemicals which are contributed by the plastic waste. And in our, we all know that the municipal solid waste rules are there. So there is a provision to find the defaulter, that is anyone who is throwing plastic in a public place, he can be fined up to 25,000. And even if you throw the plastic in our own premises, there is, as per the rule, 5,000 fine can be imposed. But it is very difficult to impose this type of rules in India. So whatever plastic which is disposed or which is dumped into the environment, it finally it goes into the water bodies, and they are carried away to the oceans as well as seas. So globally, there was one study published in the year 2017, which estimated the amount of plastic waste which is entering into the oceans by different rivers. The topmost river is Yangtze River in China. It contributes around nearly 332 kg of tons of plastics per year. Then the next is our Ganges, contributed combinedly by India and Bangladesh. It contributes around 11.5 lakhs tons of plastics per year. Then remaining most of the rivers are from main rivers are from China and other Asian countries like Indonesia, Philippines, Myanmar, Vietnam, and some few African countries like Nigeria. Yeah. So most of these rivers are located in the Asian countries, especially South Asian countries. So this is again the plastic waste which is entering into the plastic waste which is generated by top 20 countries based upon the mismanaged plastic waste. That is the plastic waste which is thrown into the environment without any segregation or without any treatment. So this is the ranking of different countries, and probably we are at number 12. Compared to other countries, we are a little bit better. Maybe China is the number one, followed by Indonesia, Philippines, Vietnam, Sri Lanka, Bangladesh, South Africa, and India. So our place is at number 12. So the per capita percentage of mismanaged plastic waste is India is it is 1.9 percentage. Then China ranks at the top. So we have seen that the whatever plastic which is entering into the ocean, part of the plastic it gets deposited because of the higher density of the plastic, and it settled into the bottom of the sea, and it settled along with the sediment. And some of the plastics which are lighter, and these plastics they further degrade, and they were broken down into smaller pieces. And these pieces they mostly they float on the surface of the sea. So if you look at, there is one great Pacific garbage patch. So this patch is located on the west of United States. It is called as the Great Pacific Garbage Patch. The area of this garbage patch, plastic patch, garbage patch is it is around 1.6 million kilometers square, and our area is it is the whole India is 3.2 million kilometers square. So it is roughly half the size of our country. And 80,000 metric tons of plastic debris that is occupying this patch. And almost 92% of the mass of this plastic is very small plastics. That is plastics of size less than 5 micrometer. So plastic particles of size less than 5 micrometer is less than 5 millimeter. It is called as microplastics. So this great Pacific garbage patch, it constitutes nearly 90% of this plastic is less than 5 millimeter size. So this size range of plastic is called as microplastics. So globally, there are 8 million tons of plastic waste entering into the sea every year. So every year, around 8 million tons of plastic waste is entering into the sea. And the plastic waste, so far, humans have produced, consumed, and disposed and entered into the sea. It is roughly around 150 million tons. And plastic, around 62% of these plastics are mainly the single-use plastics. Mainly they were used for the plastic packaging. So out of the roughly around 150 million metric tons of plastic which already present in the seawater, roughly 62% of the plastic is mainly they are meant for they came from the packaging sector. And in the year 2004, there was 1 kg of plastic. If we estimate the relative weights of plastic as well as the fish, for every 1 kg of plastic, there were 5 kg of fish in the year 2014. So if you compare the predictions by the year 2050, if the current rate of plastic waste which is entering into the sea, if it continues, so by the year 2050, there will be more plastic than the fish. So currently there are more fish than the plastic, but if the situation continues, by the year 2050, there will be more plastic in the sea than the fish population. So this is a comparison about the global primary plastic waste generation from the year 1950s, because this 1950 is reckoned as the industrial production of plastic waste. So from 1950s to 2015, roughly 330 million metric tons of plastic waste are generated per year. So these are the different type of polymer categories. You can see that LDPE as well as HDPE, they constitute the most of the polymer type. So these two plastics are mainly used for the packaging sector. And polypropylene next, then polystyrene, then PVC, polyvinyl chloride, then PET bottle, then polyurethane foam, and different type of plastics. So the main plastic polymer type which is consumed by us is mainly the LDPE, HDPE, and polypropylene and polystyrene. So this is the scenario. What would be the scenario if the current current rate of plastic consumption as well as generation of waste, if it continues, globally this would be the scenario. So mainly the China as well as the South Asian countries, including India, Pakistan, Bangladesh, Myanmar, Indonesia, as well as other countries located on the southeastern region. So they are predicted as the most the countries which are mainly producing the most of the plastic waste, which is entering into the sea as well as on the land. So we have seen that this is a plastic waste generation, and which is entering into the our inland waterways, and finally which is going into the sea. It is a global problem. So because once the waste go into the sea, it is not only the countries which are producing, other countries also face the problem. So it becomes a global problem. So to address this global problem, there are some international conventions which are also working to arrest the plastic which are entering into the ocean. So one such convention is the Basel Convention. Probably some of you might have heard about this Basel Convention. So this Basel Convention, it deals with the control of transboundary movement of hazardous waste and their disposal. So till the year 2019, plastic waste was not considered as a hazardous waste. So because of this, many developed countries, they started exporting their plastic as well as their used plastic items like electronic items, computers. They started exporting this to developing countries like India, China, Indonesia, and other even African countries. So after exporting this in the name of recycling, this becomes waste into the country which is imported. So to address this problem, this Basel Convention has listed this plastic waste as a hazardous waste. So by amendment in the year 2019, Basel Convention has listed plastic waste in the category of hazardous waste. So once it is listed under the hazardous waste, the country which is importing as well as exporting, they need to exchange the information that is called as the prior informed consent. So the company, for example, one company situated in India, which is importing plastic from, for example, from Europe. So the agency or the company which is exporting as well as the company which is situated in India, which is importing company, they have to exchange the information to the government of India that such an this much quantity of plastic is imported to India for so and so purpose. So this procedure is called as the prior informed consent. So based upon this prior informed consent, government of India may take either they may refuse or they may restrict the entry of such type of waste into their country. So this is applicable to all the countries. So this proposal was put forth by Norway. This proposal has been accepted by the United Nations Environmental Program, and plastic waste is currently listed as the hazardous waste. So now the exchange or the exporting, importing of plastic waste, it is somewhat it is restricted. So if we come to the our Indian scenario, the plastic waste generation, it is roughly around 9.4 million tons per annum. So per day generation of plastic waste is roughly 26,000 tons of plastic waste is generated per day. So out of this 26,000 plastic waste generated per day, only 10% of the plastic is recycled, and remaining 94,000 tons of plastic is left unattended in the environment. That is, it is disposed into the environment improperly. So this mainly causes the pollution of land, soil, air, and water pollution. Then 70% in the mismanaged plastic, that is roughly 70% of plastic are contributed by the packaging sector. So within a very short period of time, they becomes waste. So once the pack is opened, then the packaging has to be disposed. So their life is very short. So within a very short period of time, this type of plastic packaging, it has become a waste. So if you look at the consumption of plastic in India from 1996 to 2017, it has a very phenomenal increase in the consumption of plastics in India. So if you compare the production of plastic waste generation by states, Maharashtra tops the list, then followed by Gujarat, Tamil Nadu, UP, and Karnataka. So these are the top 5 states which are producing maximum of plastic waste in India. So we have seen the global issue, plastic waste. It is a global issue as well as the status in our country. So under these circumstances, we all know that United Nations, they have proposed 17 sustainable developmental goals. So countries has to work to attain these sustainable development goals by the year 2030. So that is the ambitious goal which was put forth by United Nations. So all countries are working towards to attain these 17 sustainable development goals. If you look at this, several of these sustainable development goals, they are highly interrelated. Mainly, there is a close relation between chemicals and waste management and sustainable developmental goals. So if you look at the, for example, the first SDG, that is no poverty, no hunger, good health and well-being, good drinking water, then responsible consumption and production, then sustainable cities and communities. So clean water and sanitation. So all these are highly, very deeply interlinked with the chemicals and waste. So there are based upon the polymer type, totally there are 7 type of major polymers are there. So this different type of polymers are given different polymer resin codes. You might have seen in different products. For example, this type of logo or symbol you can find in most of the plastic items. PET, which is which comes in the category of 1, then HDPE 2, PVC 3, then LDPE 4, then polypropylene 5. So this is called as the polymer resin code. So this polymer resin code, mainly it indicates the recyclability or the difficulty in recycling. For example, polymer code 1, PET, HDPE, PVC, they are very easily recyclable. Whereas the higher numbered one, for example, polystyrene and polypropylene, they are very difficult to recycle. So the polymer code, it indicates the difficulty in recycling. So it is not only the plastic particle per se, the other additives which are present in the plastic, they also cause various type of contamination problem. So let us see what are the different additives present into the plastics. So the major category of additives present in plastic is mainly the plasticizers. So these plasticizers, it may go up to 40% in the by mass of the plastic. So it is one of the major category of chemical or additive which is present in most of the plastics. The plasticizers, there are different types. Mainly, the most frequently used plasticizer is phthalic acid esters or phthalates. And this phthalates or phthalic acid esters, they are one of the endocrine disturbing chemicals. Then the next category is called as fillers. Fillers are generally, they are inert material. They just give more strength to the polymer. So mainly they are inorganic salts like calcium carbonate, talc, silica, clay, calcium sulfate. So then mica, glass beads, and alumina. So the fillers are mainly, they are inorganic chemicals, but most of the filler materials are they are inert materials. Then comes the other one most hazardous additive is the flame retardants. So plastics are highly flammable substances. So to make it more, to give flame retardant property, many chemicals are added. Mainly, there are the category called as brominated flame retardants, as well as short and medium chain chlorinated paraffins, then organophosphate flame retardants, and very little antimony oxide is used. So the main category of flame retardant is mainly brominated flame retardants and short and medium chain chlorinated paraffins. So these two compounds, these two category of compounds are classified as persistent organic pollutants, and they leach out of the polymer matrix or plastics into the environment. Then there are other category called as stabilizers. They add stability to the plastics, because plastics they become easily brittle when exposed to moisture or atmospheric sunlight and air. So to give more strength, lead and cadmium compounds are added. Then some plastics, some antimicrobial or some biocides are added. Mostly they are arsenic compounds, organotin compounds, triclosan. So mainly this type of compounds are added, which are mainly added to the plastics, which are mainly in constant touch with water. Then another one more category of additives, mainly they are called as antioxidants and UV stabilizers. So these compounds are generally, they are bisphenol A, then nonylphenol phenol and benzotriazoles. So these compounds, they resist the degradation due to the UV light. So UV light is one of the major threat to the plastics, because UV light it disintegrates the polymer matrix. So in order to protect the life of the plastic from the UV light, some of the compounds called as UV stabilizers, mainly benzotriazoles, nonylphenol phenol and bisphenol A. So these are the compounds, they are mainly added into the plastic to give more long life. But if you look at the hazardous properties or toxic properties of these additives, most of these compounds are endocrine disturbing compounds, and some of the compounds are classified as class 1 or class 2, 2A and 2B carcinogens by the IARC. And most of the, some of the other compounds like lead and cadmium, they are also highly toxic in nature. And all these compounds are, since they are present as additives, they are not bonded towards the polymer matrix. So they easily, they come out of the plastic and leach out into the environment. Then let us see how plastics get disintegrated and forms the microplastics and other smaller plastics. So we have seen that plastic is the major enemy of plastic is the sunlight, especially the ultraviolet UV light. So to protect the plastic from UV light, mainly the UV stabilizers like benzotriazoles and other compounds, some of the other compounds are added. But even though sunlight has a very huge disintegrating or damaging effect on the plastics, you might have observed that plastics which are exposed to sunlight, they become very easily brittle. So due to, yeah, any comments? Any comments from participants? Okay. Yeah. So due to various reasons, the plastics which are disposed into the environment, that is the mismanaged plastic waste or the improperly disposed plastic waste, which is exposed to sunlight, then atmospheric oxygen, then moisture. So these three agents, as well as the mechanical action due to wind, as well as other agents. So because of these forces, mechanical action, then air, sunlight, and moisture, this has a very damaging effect, and it leads to various mechanical as well as photochemical degradation reactions, as well as some of the bacteria also, they degrade the they help in the degradation of the plastic. So the plastic which is thrown into the environment, slowly they get disintegrated. They become smaller in size, and due to various the same biotic and abiotic factors, they are broken down or they are disintegrated into smaller size plastics. So based upon the size of the plastics, we can classify into macroplastics. That is more than, if the size is more than 25 mm, then it is called as macroplastics. Then mesoplastics, 25 to 5 mm mesoplastics. Then less than 5 mm, it is microplastics. Then less than 1 nanometer, it is called as nanoplastics. So this is how the plastic gets disintegrated, but it takes very long time. Long time in the sense it may take decades or even 100 years to disintegrate the plastics into smaller size particles. So coming towards the microplastics. So microplastics are plastic particles which are less than 5 millimeter size. So smaller plastic particles less than 5 mm size, they were detected in the coastal waters from in the year roughly around 1970s. So it was first reported by Carpenter et al. In the year 1972. So at that time, nearly 50 years back, at that time, it did not catch the attention of scientists or other policymakers as well as regulators, because no one was interested in knowing, because that was the time when the use of plastic was very huge. Then roughly 22 years later, in the year 2004, Thomson et al. He published a very good, very prominent paper in the journal Science. So he quantitatively he estimated the amount of plastic waste which is getting into the sea every year. So this paper of Thomson et al. In the year 2004, it is one of the very remarkable publication, and it caught the attention of more scientists as well as policy makers. And Thomson is the first person who introduced the term microplastics. So till then, the word microplastic was not very common. It was not known, even it was not recognized by the scientific community. So only after the year 2004, Thomson he introduced the word microplastics to describe very small pieces of plastics which are mainly present in the coastal atmosphere. So many since the Thomson's article in 2004, subsequently the research as well as the other R&D work on microplastics, it got momentum, and since then during the last 5 to 10 years, there is a very phenomenal growth of published articles in the scientific literature. So the generally accepted definition is the size range of microplastic is 1 micrometer up to less than 5 millimeter. And this definition, it was introduced by Thomson, but there are some others who says that microplastic should be considered as less than 1 mm, 1 micrometer to 1000 micrometer, and not this millimeter range. So there are some controversies, but the generally accepted definition of microplastic is 1 micrometer to 5 mm. Then there are some other category of microplastics, that is water soluble plastic. So whatever plastics, different type of polymer type we have seen, most of them are highly inert and they are insoluble in water. So at the same time, there are some plastic types which are soluble in water. For example, polyethylene glycol, polyacrylamides, polyacrylic acid copolymer, and polyvinyl alcohol. They are water soluble, and these particles are not considered as microplastics, because some of these microplastics are soluble in water and they are mainly used in personal care products. So this is the different size categories of plastic waste. So we have seen more than 25 mm, it is macroplastics, then 25 to 5 mm meso, then less than 5 mm up to 1 mm, that is called as microplastics, then less than 1 micrometer is called as the nanoplastics. So we have seen that the most acceptable definition of microplastic is 1 micrometer to less than 5 millimeter size. So there are not only the size range, different shapes of plastic is also observed. So we can see that there are 4 type of different shapes of microplastics are available. Some of the plastics, they are fibrous in nature. Mostly they are originating from the textile. Mostly these fibers are originating from the textile size. And plastic pellets, they are spherical in shape. There are 2 categories of microplastics. One is called as the primary microplastics, and another one is called as the secondary microplastics. So what are primary and secondary microplastics? Primary microplastics are mainly they are manufactured for some specific purpose. For example, most of the domestic cleaning products, most of our washing powder, as well as the personal care products which we use. So they are plastics, smaller plastics particles are added intentionally for some beneficial action. They give some good abrasive action so that cleaning action will be more. So even in toothpaste as well as the facial cleaning, various other creams, these primary microplastics are added. So they are spherical in shape, and these plastics which are added purposefully, they are called as the primary microplastics. And the second category is called as secondary microplastics. So these plastics are generated because of the disintegration or the degradation of the plastic waste which is entering into the environment. So we have four type of based upon the shape, we can be classified, and fibers. Fibers are mainly originating from the textiles. Then pellets, they are mainly manufactured as a primary microplastics. Then fragments are mainly composed of these secondary microplastics. They originate from the degradation of the higher sized particles. Then films, they are generally originate from the single-use plastic type. Then there is one more category called as foam. They are generally spherical in shape. Mainly they originate from the plastic type called as polyurethane. So let us have a little bit closer look into the primary microplastics. So we have seen that the primary microplastics are there added purposefully for some beneficial purpose into various products. For example, they are added into the mainly toothpaste. Then they are added into various cleaning products because they give very good abrasive action. So mainly they are added into the cosmetic products, then detergents and cleaning products. Then some of the fertilizers, they should be they are designed for a controlled release of formulations, controlled release formulation fertilizers and other plant protection products. Then even in some of the medicines also, these primary microplastics are added because they release the active ingredient of the medicine after once it reaches into the stomach and after some specific time gap. Then some of these primary microplastics are added into the used as a food additives also, because it gives some good aesthetic appearance as well as some good taste. So because of this property, and most of these primary plastics added into the food additives, they are soluble in nature. So predominantly polyethylene, both LDPE as well as HDPE, polypropylene, and polymethyl methacrylate, polystyrene, and polyethylene terephthalate, PET plastics. So these plastics are mainly added as the primary microplastics. And most of these primary microplastics, their size, it ranges from less than 100 micrometer to 1.5 mm. And it depends upon for what purpose, what is the purpose of adding these primary microplastics into the different products. Then cosmetics, it may contain around 0.05 to 12% of microplastics, depending upon the purpose for which it is produced. So the presence of microplastics, mostly the microbeads, which are present in cosmetics, it attracted the regulatory action because of the knowledge, scientific knowledge, which is generated during the last 10 to 15 years. So various countries, mainly the developed countries, they took some regulatory action. So mainly these microbeads, they were mainly introduced into the cleaning products or the personal care products roughly as a exfoliating agent, that is abrasive action in the cosmetics roughly around the year 1990s. So previously mainly the aluminum oxide and other natural materials like starch and pumice pills, these were mainly used as before the introduction of the plastics by the year 1990. So they are added for various functions like skin exfoliation and cleaning action, then opacity control, and they also impart smooth and silky feeling and illumination of the skin and viscosity control. So these are mainly highly desirable properties, especially for the cosmetic industry. Then compared to the inorganic products, mainly the aluminum oxide as well as the starch and other natural materials, these microplastics, they are less rough and offer very smooth exfoliation. So this is one of the good property. Most of us like to have this property compared to the use of inorganic material. So they are less rough and offer very smooth exfoliation. And compared to the inorganic materials, these microplastics are very cheaper. They had very lower density. So it was very easier to wash off without blocking the drainage, and they are highly compatible with the other compounds in the products and did not cause damage to the container. So these are some of the favorable or desirable properties. So because of this, the addition of microbeads or microplastics in cosmetics and other as well as other cleaning products, it was highly encouraged, and their quantity it ranges from 0.05 to 12% in the final products. So what are the probable adverse health effects of microplastics? Mainly there are 4 type of adverse effects are possible. One is due to the particle toxicity or physical toxicity. So it can be mainly compared to the particles which are mainly present in the considered as air pollutants. For example, particulate matter 10 PM 2.5. So the main their particle toxicity is comparable to the particles present in the ambient air. Then their size, shape, surface area, and chemical composition. So, but there are always two sides. So some of the scientists they argue that these plastic particles they are mostly inert particles. They are also likely to cause toxicity similar to the particles present in the ambient air. But the scientific truth is most of the plastic polymers they are highly inert. And microplastics of size more than 100 micrometer, they are not likely to be absorbed in most of the studies conducted so far, and they did not show any toxic effects if the particle size is more than 100 micrometer. And no epidemiological studies are linked towards the adverse health effects to the microplastic size of more than 100 micrometer. So, so far, based upon the published literature, the evidence of particle toxicity is very poor. So there is a very less amount of data is available to support the hypothesis. Then coming towards the next one, so the particle toxicity we have seen. The next one is the polymer additives. So we have seen that many chemicals are added to the plastics to impart various functionalities. So polymer additives, residual monomers, and catalysts. So most of the monomers, for example, acrylamide 1,3-butadiene, ethylene oxide, and vinyl chloride. So these are some of the highly dangerous additives. Then the next category is plasticizers and flame retardants, polybrominated diphenyl ethers, organophosphate flame retardants, UV stabilizers. So these are some of the highly hazardous additives. Their toxic effect is evidence is very strong. There is sufficient data is available to support the hypothesis that they are a cause of concern because of the adverse health or the toxic nature. So in addition to the additives which are added into the plastics, the plastic particles, especially the micro-sized particles, because of their very high surface area, they have the capacity to absorb some of the contaminants present in the environment. So it is not only the additives which are present, the particles also absorb some of the contaminants which is present into the environment, mainly some of the organic contaminants, heavy metals, and the persistent organic pollutants, like for example, polychlorinated biphenyls, polycyclic aromatic hydrocarbons. So these are some of the contaminants which are present or in the environment, and these get enriched on the particles. So to support this hypothesis, the evidence for the absorption of these contaminants into the microplastics, their evidence is strong. Then there is sufficient data is available to support the hypothesis, but the exposure data is very weak. That means we have sufficient evidence, but at the same time, considering this human exposure, very limited evidence is available to support the hypothesis that these microplastics have good absorbent properties, and because of this enrichment of these pollutants, human beings are at risk. Then in addition to that, biofilms. So when plastic particles are in the environment, microorganisms start developing on the surface of the plastic particles and they form biofilms. So these biofilms, they are the colonies of microorganisms, and they also likely to pose certain hazardous as well as toxic properties. So we have seen three type of possible hazardous effect. One is due to the physical toxicity, that is due to the particle toxicity. Then second one is the chemicals which are added as additives. The third one is the chemicals which are or the contaminants which are adsorbed from the environment. So these are the three, and biofilms. So these are the four categories of hazardous properties or possible toxicity due to microplastics. Then we have seen these are the four hypotheses. We have seen the published literature and the data regarding their to support this hypothesis, as well as in not to support this hypothesis. So then, what is the concern about this? Why microplastics are considered as hazardous or harmful to human beings and other organisms? So the first point is microplastics are very small in nature. So because of this smaller size, they are readily available and potentially susceptible to transfer within the food chains. So this is one of the hypotheses that microplastics, because of their smaller chains, they get into the food chain and they get transferred to the members which are into the other trophic levels in the food chain. And they are very resistant for the degradation, that is environmental degradation, both biotic as well as abiotic degradation, and they are persistent in the environment for a very long time. And microplastics, they fragment further into nanoplastics, and once they are converted into micro as well as nanoplastics, these smaller particles, they can easily get into the air, and human beings can easily breathe, and these particles can reach easily into the alveoli as well as the bloodstream as well as the placenta. In fact, there are some evidence to support this hypothesis that microplastics are also detected in human lungs as well as in the blood as well as in placenta. So we will see in the coming slides. And it is practically impossible. Once microplastics are found into the environment, it is practically impossible to remove any by applying any removal technique. And these microplastics are included in the European Union REACH regulations. Because of its very persistent criteria, they have been included in the European Union regulations. So coming towards the presence of microplastic, we have seen that microplastics both are present in the primary microplastics. They are internationally added into some of the products, especially the cosmetic industry. Many world over, there were several oppositions, especially from the non-governmental organization, that is NGOs, to ban the addition of microplastics in most of the personal care products. So let us see some of the facts. So how these microplastics are produced in our day-to-day life. For example, all of us use washing machine for to wash our clothes. So a single washing machine load can produce up to 7 lakhs of microplastics fibers. So this is one of the study. A single washing machine for a single run, it can produce up to 7 lakhs of microplastics for a single run. So if we run our washing machine one time, that itself is generate around 7 lakhs microplastic fibers. Then one time face wash. So if we wash the face wash by using the commercial products, that itself will generate 94,000 of microbits. But most of these microbits are soluble in nature. So to address this, the possible adverse health effects, there are various countries, especially the European countries, they took a very proactive action. And in the year 2014, Netherlands was the first country to introduce ban on the microplastic addition into the cosmetic products. So subsequently, several other European countries, especially the developed countries like Australia, Canada, European Union, Italy, Korea. So many countries have banned the addition of microplastics into the cosmetic products. So we have seen various news items in even in our India also. Many both print as well as electronic media, they recently published a lot of interesting news about the microplastics. So this is the Times of India news in the 2021. So it is a very good article which summarizes about the presence of microplastics in salts which is produced from sea. So it compared the different type of salts produced from sea salt. So most of the because sea is the ocean is where all the plastic waste finally get into. So the salt which is produced from sea, it contains lot of microplastics. It is one of the interesting article. Then this is also one article which came in the Times of India Chennai edition. Then in fact bottled water which we all prefer, which contains more microplastics than the tap water. So this is one of the interesting article which came in Times of India. And at the same time, microplastics are also noted in the human blood also. So against this different various news items, the National Green Tribunal, NGT, so they took so much action, and they asked about the Central Pollution Control Board to file an affidavit about the various news items produced in, which appeared in the newspaper. And this is the reply filed by Central Pollution Control Board. So there were some interesting news articles, published literature on the presence of microplastics in various human body fluids. For example, in the journal Environmental International, the first discovery and quantitation of plastic particles in human blood, it was reported. Then microplastics are also reported in the human feces as well as human urine as well as human placenta. So placenta should not be called as a placenta, it should be called as a plasticenta, because it contains small plastic particles. So various evidences were published recently in the published literature about the presence of microplastics in different human body fluids. So how human beings are exposed to the plastic particles. So we have seen that we are exposed to plastic particles through personal care products, which we generally use. Then seafood, mainly fish and other sea organisms, because sea is one of the final disposal site for most of the waste, including plastic waste. So sea fish contain more of microplastics. Then plastics which are just disposed of in improperly disposed on land as well as water bodies, they slowly degrade and get into the through air as well as through water, then through different food materials. So finally it will come on our table, and we are consuming all these items. So it is a ubiquitous pollutant. Now it has become a ubiquitous pollutant, and nobody can escape from the adverse effects or the exposure of microplastics from the food chain. So if you look at the contaminants which are leached out from the plastics, we have already seen the different type of additives, mainly the fillers, stabilizers, plasticizers, biocides, flame retardants, then antioxidants and UV stabilizers. Then plastics, when they are burned, they release some toxic organic compounds like dioxin and furans, polycyclic aromatic hydrocarbons, styrene, polychlorinated biphenyls. So all these are released into the atmosphere when the plastic waste is incinerated or burned. So taking the presence of microplastics, World Health Organization, it took so much action, and in 2019 they published one report which says that in drinking water, plastic particles may present from BDL to 10,000 plastic particles per liter. But at the same time, at present, there is no sufficient information is available to support that human beings are exposed to plastics. But at the same time, there is not sufficient evidence is available to conclude about the toxicity of microplastics. And this Food and Agriculture Organization of United Nations, they also reviewed various published literature regarding the exposure of microplastics through food chain. So they also came to the conclusion that at present there is not much sufficient evidence is available. So microplastics per se, it is not of much concern because of lack of evidence. So at the same time, the scientific community also reacted very sharply against this food and FAO report as well as WHO report. So there is a strong criticism. The title says that absence of evidence does not mean evidence for absence. So both WHO as well as FAO report says that there is not much evidence is available to conclude that microplastics are toxic to human beings. So the criticism says that absence of evidence does not mean evidence for absence. So United Nations also took the the cognizance of these problems posed by plastic waste and microplastics. And in fact, last month there was one meeting in Paris. So it was about bringing some international regulation to legally binding international regulation to minimize the plastic pollution into the marine environment. So coming towards the how we can analyze these microplastics in the environment. So this is the sequence of analytical procedure. So the sample, which may be soil, sediment or water, first it has to be collected by suitable sampling procedures. The sampling may be a grab sample or composite sample or any other type of sample. So when the samples are first collected, for example, if you collect soil, first the sample has to be filtered, because as per the definition of microplastics, it is less than 5 mm size. So a suitable sieve of 5 mm size, it has to be filtered first. Then, so when we filter it, both is plastic as well as non-plastic, that is the soil sample as well as the plastic sample, both it will come. So by using a density separation method, so this is a very crucial step because plastic particles, their density, it ranges from 0.8 to up to 1.8. So by using a very higher density solution, plastic particles can be made to float on the surface of water. So this is one of the very crucial step in the separation of plastic from the soil or sediment or from other matrix. So once it is separated, then it goes into the different size fractions. So if, for example, many people are interested to see further classifying in the plastic into 5 mm to 2 mm, then 2 mm to 1 mm, then less than 1 mm, less than 100 meter. So we can also further we can divide the microplastic into different categories based upon the size. And for this we require sieves of suitable size. So once it is separated, then further it can be subjected to the a digestion procedure. So this procedure is mainly used to remove the organic matter which is present on the plastic particles. So once a digestion procedure, mainly very weak acids as well as hydrogen peroxide is mainly used to remove the oxidize the organic matter. So once it is oxidized, then further it comes to the filtration. Then finally the identification of the polymers, they are mainly done by different type of spectrometric techniques like FTIR, then Raman spectrometer, then atomic force microscope, then pyrolysis GCMS, differential scanning colorimeter, then scanning electron microscope. Different instrument techniques are available for the identification of the polymer type. Then by using microscope, we can characterize the size, shape, color, as well as the particle counting by using the microscope. So this is the sequence of analytical procedure, general analytical procedure used for the analysis of microplastics. So we have conducted a very recently one study in Nagpur. So we have seen that mainly the plastics are the plastics which are thrown into the environment or which are just littered into the environment. they are the major source of plastics. And we have collected nearly around 40 samples in different dumping sites. Mainly they are the corners of streets, then water bodies. So these are some of the sampling sites, mainly from the different urban areas of Nagpur city. And we have classified the areas into residential, commercial, and industrial area. And our result shows that the residential areas are the major areas where the microplastics are more compared to commercial and industrial areas. So it shows that human beings are the culprits of the microplastics which are introduced into the environment. So these are the different sampling sites in the Nagpur city. So the plastic size range, it depends upon the size range. The previous one is for 5 to 2 mm. So this is 1 to 2 mm. So we have found that more particles are found in the lower size range. The higher size range is less compared to the lower size range. And the number of particles is in terms of lakhs. So the maximum concentration we found up to 4.8 lakhs. This is the maximum 4.8 lakhs particles per kg of soil. So there is a one global monitoring study which is going on, which is mainly monitoring the organic pollutants, especially the persistent organic pollutants, which is adsorbed on the plastic resins. So this is the concentration of hexachlorocyclohexene on the beach pellets. So there is a university from Tokyo, Japan. They are coordinating this one. So they collect samples throughout the vent, mainly from beach. They collect and they analyze the persistent organic pollutants which are adsorbed on the surface of the microplastics. So from India, 2-3 places the sample is being collected, and the concentration of the persistent organic pollutants are very less compared to other countries. So mainly the South Asian countries, as well as the Africa, as well as the Eastern Europe, the concentration is much high. So this is the same about the presence of DDT and its metabolites. So the same scenario, and this is about the polychlorinated biphenyls, right? So we have our government also published a plastic waste management rule in the year 2016, but still we are implementing it, but the implementation mechanism is very poor. So what is the chemicals and waste we have seen? So many chemicals are present in the products and waste which we are producing, and they have hazardous properties, and they may have adverse effect on human health and the environment due to the mismanagement. Mismanagement means dumping into the environment without segregating or without going into the very further management, waste management. So most of the hazardous properties and the potential risk include due to the presence of plastic additives like the phthalic acid plasticizers. So most of them are classified as carcinogens, mutagens, and they have hazardous to product reproduction, persistent and bioaccumulative and toxic in nature. And some of the chemicals are endocrine disturbing in nature, and they have adverse effects on neurodevelopmental effects. So sound management of chemicals and waste, as called for internationally at the highest political level during several major United Nations conferences, is essential for achieving the sustainable developmental goals across social, economic, and environmental dimensions. Then there is a lack of evidence and data. So since there is a lack of evidence or data, we should not postpone any taking remedial action. So this is called as the precautionary principle. That is, the lack of scientific evidence should not be used as a reason for postponing for any remedial action or taking any action. So there is a few more slides are left out. So I will quickly finish this one. So there is a close relation between hazard, risk, and perception among public regarding the microplastics. So currently, based upon the current evidence or available data, shows that there is no sufficient evidence is available to come to the conclusion that microplastics are toxic in nature, or they are likely to pose adverse health effects. But at the same time, as per the precautionary principle that lack of evidence should not be the reason for postponing for taking any actions. So generally, people fear things that do not make them sick, but that people get sick from things they do not fear. So this is one of the famous quote. And the term microplastics was not known to most of us till a decade ago. So presently, the scientific community is aware about the term microplastics, and the awareness is increasing. And people, the more we become aware, the more we become concerned. And microplastics have hazardous properties, but our knowledge on the hazardous properties are well established. But at the same time, our exposure as well as the risk, our knowledge about exposure and risk is very minimal. And there are various other factors like socioeconomic and cultural background of us. Also, it influences the how we perceive the environmental risk. And of course, media, we have seen many print and electronic media, they play a major role in communicating the scientific knowledge to common people. So in summary, the predominant exposure pathway of microplastics is food. Food is the major source of human exposure to microplastics. And uptake of microplastics, the ingested microplastics of more than size 150 micrometer is insignificant. That is, most of the plastic particularly ingested is it is expelled through the feces as indigested. Then only 0.2 to 7% is indicate it is absorbed in, via the food intake. Then particles of size less than 1 mm was only 1.5 to 10% of uptake, and the rest is eliminated via the feces. And our current knowledge is insufficient to make any conclusion about the whether the microplastic is whether the human beings are really at risk or no risk. So, however, it is always the precautionary principle which always hold good. That is, the lack of evidence should not be the reason for postponing to taking the any action. So, at the same time, the additives which are present in the plastics, they are of very major concern. So, given the overall impact of microplastics as well, plastic waste as well as microplastics, it is better to minimize the usage of the plastics in our day-to-day life as far as possible. So that is the end of this presentation. So I would be happy to answer questions from the participants. So thank you very much.
Now I would like to request participant, please ask your queries one by one.
Sir, I would like to thank you for giving the information on plastics, that is microplastics used in personal products, particularly medicines and face care products and all. Sir, I didn't have any knowledge about this one still now, sir. So first of all, thank you so much for this one, sir. And I would like to ask you one question, sir. If this keeps on continuing, what will be the final outcome?
Sorry, could you repeat the question?
Sir, if this pollution, if this thing keeps on continuing day to day, our daily usage of plastics keep on increasing in every sector, what will be the final end result?
Yeah, good question, but very difficult to answer. See, coming towards the the perceived toxic effects of microplastics in personal care products, various developing countries, they started banning the addition of primary microplastics into the personal care products. But again, taking regulatory action, all it depends upon the awareness level as well as the policy decisions they are taken by the government only. And many government as well as central government, they completely banned the usage of single-use plastics. I think last year July onwards. So currently, the usage of single-use plastics of size less than 120 micrometer, it is totally banned. But at the same time, illegally also a lot of things are happening. I'm not getting into that. Maybe when the regulations become more tightened or more more enforcement is there, then the usage of single-use plastics will gradually it will come down. But at the same time, as citizens, we should also be aware about the adverse effects of most of the additives which are present into the plastics. Maybe further regulatory action is also required from the government side to use the safe additives. All these additives, they have alternatives which are less harmful. Maybe regulatory action may require further, but again it depends upon the awareness among the policy makers as well as the at the highest political level. Yeah, that will only reduce the hazardous effect of these additives present in the plastics.
Thank you, sir.
So at the personal level also, we can also take our own actions. So we need not to wait for the government to take regulatory action. So given the awareness level of the people, we can also take our own at our level. So any other questions from participants?
Sir, as I remember, the who has created this polymer plastic, I think he has got a Nobel Prize for that. And now we are facing so much problems.
Yeah. So can we get back the Nobel Prize?
I don't remember the name, sir, but
Okay.
no, but he yes, he has got the Nobel Prize for this new innovation. But
Yeah,
even
yeah.
though we are facing some problems after 70 years after that, so such these inventions should be checked at that time only. That I wanted to ask you whether it is
Yeah,
true or
see, it's a good question. See, we are talking about the adverse effect or possible toxic effect because we are aware. Presently, we are aware. So when the plastics were introduced at that maybe roughly around the 1915s, that time our awareness and knowledge level it was very less. Scientific knowledge about the because that time people were thinking only about the advantages. In fact, plastic is it brings many societal good beneficial effects. So at that time only the beneficial effects were or beneficial things were considered. But later on, when we become aware, then we are more concerned. Maybe it is a good suggestion. Maybe can be useful for regulatory and policy level of taking actions.
yes, after some years, even if it has got very much means it has a way what should I say that benefits of it when we realize that time only it should be considered because we are given the Nobel Prize and now we are facing the problems. That was I means my concern was that only.
Yeah, good.
Thank you, sir.
Yeah. Any other comments or suggestions from participants?
Sir, I have a question.
Yeah.
Hello, sir, am I
Yeah,
audible?
yes. Yeah, audible. Yeah, please.
Sir, is melamine a microplastic?
No, see, melamine, it is a it is a resin. It is a resin prepared from urea formaldehyde. It is also a polymer, but it does not come under the category of plastic. But it is a polymer. It is prepared from urea and urea formaldehyde resin. And there was some issue in China, I think around early 90s. Some additives, toxic additives were added into the milk powder. It also exactly appears as white. As a food adulterant. Then the entire milk powder was called back. That has become a major issue. But again, there are some additives. Again, it goes into the polymer matrix for making into the products.
Even that is equally harmful, right?
Yeah, that is also harmful. So many things which we use in our day-to-day life, most of the plastic additives are harmful.
The dinner
But
set,
again,
the soup bowl you're using.
Yeah. So even there are plenty of literature is available regarding the microwaving of food.
Yeah, microwave.
Yeah. So microwaving of food, it generates more free radicals than the normal way of cooking. So free radicals are highly, they are harmful for human health. So there are plenty of literatures also available, but at the same time, literature is available for on both sides, both merits as well as demerits. So it is up to us to take proactive actions.
Okay, sir. Thank you, sir.
Okay, I think there are no more questions. So thank you very much. I thank all the participants for their patient hearing. And also I thank Dr. Meshram for giving this opportunity. So thank you very much once again. So I will share this presentation if it is required to Dr. Meshram.
Yes, sir. Yes, sir. Please, sir. I'll be requiring your presentation so that I will forward it to my group. Sir, thank you very much. Once again, I'm very much thankful for your informative presentation, sir, and the time devoted for you in spite of your busy and hectic schedule, sir.
Okay,
Now
thank you.
I would like to request one of same participant to propose the vote of thanks immediately.
Yes, sir. Thank you, sir.
Dr. Rajesh, please.
It is indeed a great pleasure to attend and assimilate an information presentation on microplastic in water environment, followed by a healthy curious session. These areas of presentation were plastic advantage and disadvantage, plastic production, plastic waste, adverse effects on environment, animals, toxic by plastic mismanagement, microplastic research, plastic pollution in marine environment, and plastic waste management. I would like to thank Dr. A. Ramesh Kumar for enlightening us with your marvelous, lucid, and up to the mark presentation. Further, I would like to extend my heartfelt gratitude to Dr. Praveen Mishram for giving me an opportunity to introduce this marvelous resource person. And finally, I thanks to all my participants who attended and enjoyed this thought-provoking session. Thank you once again. Thank you, sir.
Okay, thank you, sir. Okay, bye. Now, my dear participant, immediately do not take any break because our second